Question number 7, part A. Alright. The variables x and y are connected by the equation y is equals to 3 plus x minus x square over 2. Some corresponding values of x and y are given in the table. Complete the table. So simply substitute x is equals to minus 3 here first. So 3 minus 3 square over 2. This should give you minus 4.5. Minus 4.5. And similarly, when you substitute x is equals to 5, you will get minus 4.5 again. Okay. Next, in part 2, using a scale of 2 centimeter to 1 unit, draw a horizontal axis from minus 3 to 5, and using a scale of 1 centimeter to 1 unit, draw a vertical y-axis from minus 5 to 5. So the software I'm using does not allow me to use straight lines and curves, so I will instead use this graph here. You are supposed to make this graph yourself first using the given scale. 2 centimeter is 1 unit on the x-axis, and on the y-axis 1 centimeter is 1 unit. So make a grid from minus 3 to 5 on the x-axis and from 5 to minus 5 on the y-axis. Next, you draw the graph. So this is what the graph should look like in part 2. Part 3, by drawing a tangent, estimate the gradient of the curve at 3, 1.5. So at 3, 1.5, you have to make a gradient. So again, I don't have a ruler in this software, so I will roughly make a very bad looking tangent. Your tangent should only cut the graph at this point only. It should touch the graph at this given point only. Next, we have to, after drawing the tangent, we have to estimate the gradient. For that, you need 2 points here. So one of the points can be 3, 1.5, which is the point given to us. The next point can be any point on the line you've made. So if this very bad looking line touches the x-axis at, let's say, 3.9, let's say, so this will be 3.9, 0. So using these two coordinates, we can find the gradient. The gradient formula is y2 minus y1 over x2 minus x1. So y2 is 0 minus 1.5 over 3.9 minus 3, and you'll get your answer here. I will get a very inaccurate answer. Let's see what I get divided by 3.9 minus 3. I'm getting minus 1.6, minus 1.66666, so rounded off minus 1.7. Marking scheme says your answer should be between minus 4.2 to 1.6, so minus 1.6. Coincidentally, it's lying in this range. Yours should too when you make an accurate tangent using a scale. Okay. Part 4. The points of intersection of this graph and the line y is equals to k are the solutions of this equation. Find the value of k. So like I've taught you in the class, figure out what can be eliminated from these two equations to get an equation like this. So where k is a constant. So rearranging the first equation, I can, before that, we can, by looking at these two equations, we can tell that x square can be eliminated, and hopefully x will get eliminated as well, and we'll get something like y is equals to 3, and that 3 will be our k. So let's see how do we proceed from here. Make x square the subject over here and here as well. So in the first equation, I can write 2y is equals to 6 plus 2x minus x square and make x square the subject, so x square is equals to 6 plus 2x minus 2y, right? And when I make x square subject here, I get x square is equals to 2x plus 10. Now we can substitute, we can eliminate x square and get 6 plus 2x minus 2y is equals to 2x plus 10. X is being eliminated like it should, and we get minus 4 is equals to minus 2y, so y is equals to, plus 2y. Minus 4 is equals to plus 2y and y is equals to minus 2, so k is equals to minus 2. Part B, by drawing the line y is equals to k, which is the line y is equals to minus 2, on your graph, find the solution of this equation. So all you need to do is go back to the original graph. Here plot the line y is equals to minus 2. So y is equals to minus 2, which will be a line like this. You get that line, and now see where it is cutting your graph. So one answer is this value of x, read it out, and the other one is this value of x. So this will be anywhere between minus 2.4 to minus 2.3 according to the marking scheme, and this one can be anything between 4.3 to 4.4. Part B. This is a sketch of the graph y is equals to PAX, where a is greater than 0. The graph passes through the point 0, 4 and 2, 36. These points are very important. They will be used to solve the question along with the given equation y is equals to PA power x. Write down the value of P. So I'm doing part 1 here. Y is equals to PA power x. Now by using 0, 4, I get 4 is equals to PA power 0, which means P is equals to 4 is the first answer. Next, find the value of A. So for part 2, now the equation can be rewritten as y is equals to 4a power x. Now I may use 2, 36. So y is 36 is equals to 4a power 2. So 36 divided by 4 is 9. 9 is equals to a square. A will be plus minus 3, but we're only going to use positive 3 because the question says a is greater than 0. So a is equals to 3. Part 3. The graph passes through the point 4, q. Find the value of q. So again, I'll rewrite the equation. Y is equals to p was 4, a came out to be 3 power x. Now this passes through 4, q. So that means y can be changed to q is equals to 4 times 3 power x is 4. And this will give us 324. Okay, so this is question number 8. Jumping to part A, which says for each of these angles as simply as possible in terms of y, find each of these angles as simply as possible in terms of y. Give reasons for your answer. So in the first part, we need to find angle GEO. So we need this angle. Okay, now what do? We know that angle at the center is twice the angle at the circumference. So this is the angle at the center, and from these two same points we have another angle at the circumference from these two same starting points. So if this is y, this is double the angle here. So this will simply be y by 2. So we'll write y by 2 here. This is y over 2, and the reason you'll give will be because angle at the center is twice the angle at the circumference. Part 2, find GCX. So G to C to X. We need this angle. So for this we know that the angle between a tangent and a radius is 90 degree. So this angle will be 90 degree. Then we can find the third angle easily by doing 180 is equals to y plus 90 plus, let's call this angle Z, plus Z. So Z in terms of y will be 90 minus y, right? So this angle here will be 90 minus y. This will be 90 minus y. Okay. Part 3, find angle DAB. So we need this whole angle. Okay. We know that sum of opposite angles in a cyclic quadrilateral is equals to 180, which roughly means that this angle plus this whole angle will sum up to 180 degree. In part 2 you also had to give the reason how we got 90 minus y. The reason will be the first reason will be because radius and tangent are perpendicular. The second reason will be because sum of interior angles in a triangle is 180 degree. Alright, going back to part 3. So cyclic quadrilateral, in a cyclic quadrilateral is a quadrilateral whose 4 vertices touch the circumference of a circle, like in this case. Then the opposite angles sum up to 180. So this angle was 90 minus x, and this angle next to it will also be 90 minus y. Why? Because this line and this line, they're equal, because these two are tangents originating from a same point, so they'll be equal in length. So sum of angle DAB plus 2 times of 90 minus y, sum of opposite angles in a cyclic quadrilateral is 180. Now rearrange this, and DAB will be equals to 180 minus 180 plus 2y. So DAB is simply equals to 2y. DAB is equals to 2y, and reason will be because sum of opposite angles in a cyclic quadrilateral is equals to 180. So this is 2y. The whole thing is 2y. Alright, then half of it will be y, and this will be y as well. Alright. This was minus y, and the whole angle is 2y. Okay. You may also solve this part by using the property that angle subtended from a diameter is 90 degrees. So these two angles will be 90 degree. So sum of this plus this plus this plus this would be 360. So you can find part 3 using this rule as well. Okay. Going to part B, complete the sentence triangle EGC is congruent to triangle EGC. This triangle will be congruent to this triangle. So we'll write a triangle EGC, this is part B, will be congruent to triangle EFC. Don't jumble up these numbers, it will come in the same sequence, EFC. Alright, part C, prove that triangle ADC, where is triangle ADC? This whole triangle, and triangle OGC, they are similar. Prove that triangle ADC is similar to triangle OGC. So for that you need to show that all angles are equal. So in triangle OGC we have an angle Y, we have an angle 90 degree, and we have an angle 90 minus Y. In triangle DAB we do have an angle Y, yes, this is Y, and also this is 90. So since two angles are equal, this is Y and this is also Y, this is 90, this is 90, and the third angle is shared between the two triangles, so it's the same as well. So you'll write that angle, you'll have to write all of the reasonings very well. So you'll write angle GOC, we're doing part C, angle GOC is equals to angle DAC is equals to Y, and then CDA, angle CDA is equals to angle CGO is equals to 90 degrees, and angle ACD is equals to angle OCG is equals to 90 minus Y. So you'll write, hence, since all three angles are equal, these triangles are similar. This was part C. Part D, what special type of quadrilateral is AODG? AODG. So this right here is a trapezium. So you write trapezium. Part E, find the ratio of area of triangle OGC. So a ratio of triangle OGC and ratio of triangle ADC, the whole triangle. And we've already established that these two triangles are similar. So we can use the formula A1 over A2 is equals to L1 over L2 whole square. We're doing E1. So this length is the radius, right? And this whole length is the diameter. And what is the ratio between radius and diameter? That is 1 over 2. So instead of L1 over L2, I can write 1 over 2 whole square, which gives us 1 over 4. So this is the answer for part E, part 1. Alright. Part 2, find the area of E2. Find the area of triangle OGC, this ratio area of the whole thing, the whole quadrilateral ABDC. So we'll use the previous answer here. Let me clear this. We just established in part E1 that if area of this is 1, then the area of this whole thing is 4 units, which means that the area of this remaining region is 3. Similarly, this will be 1 and this will be 3. So the answer for part E2 will be 1 over 3, 4, 5, 6, 7, 8. 1 over 8. Question 9, part A. The ventilation shaft of a tunnel is in the shape of a cylinder. The cylinder has radius 0.4, length 15. Calculate the volume. Volume of a cylinder is pi radius square times height. So the answer will be 7.54, correct to 3 significant figures. Part B. The diagram shows a cross section of a tunnel. The cross section of the tunnel is a major segment of a circle with center 0. The radius, which means this whole shape they've made, this is a major segment of a circle. Okay. Next, the radius is 4.5, angle AOB is 110. Calculate the area of the cross section. So this figure has two parts, this major segment plus this triangle. So for area of the major segment, we need this angle first, 360 minus 110 which gives us 250 degrees. So this is 250. So area of the major segment will be 250 over 360 into pi radius square plus area of this triangle, which the triangle underneath, which is half AB sine C, so half 4.5 sine 110. Solve this and you should get 53.7 rounded off to 3 significant figures. Part C. The length of a tunnel is 1750. The car drives through the tunnel at an average speed of 1750 meters, and the car travels through the tunnel at an average speed of 45 km per hour. Work out the time the car takes to travel through the tunnel. Give your answer in minutes and seconds. So time is equals to distance over speed. Distance will be 1.75 kilometers and speed is 45 kilometers per hour. This will give you 0.03 and a recurring 8 kilometers hours. How do we change this into minutes and seconds? I've taught you to use this key, this key in your calculator, a dot and then commas. I think 2 commas or 3 commas, let me check. A dot and 3 commas, yes. When you click that key, it will give you 0, then comma 2, comma 20. So that will mean 0 hours, 2 minutes and 20 seconds. Or you may simply multiply this with 60 first. This answer with 60 first, you'll get 2.33333. Then that will mean 2 minutes and 0.333 extra minutes. Multiply that 0.333 times 60, you'll get 20. Alright. Part D. We're given some information and we're asked to find the bearing of T from Q, which means north on Q, which is already there, and clockwise angles from this north towards line TQ. So we need this angle. For this, we can find this angle first and subtract it by 180. So for this angle, we'll apply sine rule. 450 over sine theta is equals to 720 over sine 62. So you'll apply theta is equals to sine inverse of 450 times sine 62 over 720. So this should give you 33.49. Theta will be 33.4935 and subtract it from 180 minus the calculator display, whatever that is, 33.49 etc., and you will get 146.5, correct to 1 decimal place since this is an angle. Question 10, part A. The area of this frame, the total area of the picture and the frame is 476. So the area of this outer triangle, so outer rectangle, is 476. The formula for area is length times width. Now this length is given that this is the length AB, or this length is 3 times the length x. So this length is 3x. So this will be 3x plus 2, which means 3x plus 4, and this length is x plus 2, so x plus 4. Open the brackets, rearrange, you will get the required equation right here. Okay, moving on to part B. Solve this equation. So since this is P2, you may just use your calculator. So minus B plus minus B square minus 4AC over 2a. This will give you two answers, 10 and minus 15.3 rounded off. Part C, find the height and the length of the frame. So the value of x that we'll use is 10 because the negative one can't be used because the length cannot be negative. So one length was x plus 4 and the other length was 3x plus 4. So the height was this. So the height will be 10 plus 4, which is 14, and the length was 3x plus 4, so that is 34. So this is what the rectangle looks like. This is 14 and this is 34. Alright, part D. The frame is made from wood. The wood is 5 millimeters thick. The mass of 1 centimeter cube of the wood is 0.7 grams. Calculate the mass of the wood used for the frame. Now wood will be used to make this region of the frame, right? Inside we'll have the picture. So that means we need the volume of this region of the frame, and because I'm saying volume because now it has a thickness of 5 millimeters. So this length is 5 mm. Keep that in mind. There's a conflict in the units that we'll fix. Okay, so the inner length will be 30 and this length came out to be x is equals to 10. So this is 10. Alright, so now we need the volume of the frame. So volume of the frame will be 34 times 14 times 5 millimeters is 0.5 centimeters. So 0.5 centimeters. This is the volume of the whole cuboid minus volume of the inner unshaded cuboid, which will be 30 times 10 times 0.5. So this will give us 88 centimeters cube. Now the mass of 1 centimeter cube is 0.7 grams. So 1 centimeter cube corresponds to 0.7 grams. So 88 centimeter cube will correspond to how many grams? Simply cross multiply this. X will be 0.7 times 88, which will be 61.6, which is the final answer for the mass. 11a. The vertical mast XY is positioned on horizontal ground. The mast is supported by 4 cables attached to the mast at P and to the ground at the points A, B, C, D. Y is the center of the square ABCD. PY is 7.5. So this length is 7.5. Given that AB is 3.65, this is 3.65, show that AY is equals to 2.58. Now since this is a square, if this is 3.65, this will also be 3.65, and since it's a square, this angle will be a right angle triangle. So I'll apply Pythagoras theorem to get AC first and then do half of that to get AY. Alright, so 3.65, 3.65, right angle, this will give me AC by applying Pythagoras theorem, and then I'll do half of AC. So AC will be under root 3.65 square plus 3.65 square. 3.65 square. This will give us AC is equals to 5.1618. 5.1618. Now AY will be half of AC, which will be 5.16. Sorry, AY will be 2.58 rounded off to 3 significant figures, and we've shown what they ask for. Right. Part B. Calculate the Part B says calculate the length of one of the cables used to support the mast. We know this length is 7.5 given to us in the question. We know this length AY, which is 2.58, we found in the last part. We know the angle between them is right angle, so this is AYP. We can find AP by applying Pythagoras theorem. 7.5 square plus 2.58 square whole under root, which gives us 7.93, rounded off answer. Now we're doing part C of this question, which says calculate angle APB. So we need this angle, and we have all these lengths. This was 7.93. This was also 7.93 because it's an isosceles triangle. In fact, we'll use 9316. We'll use 4 decimal places. And this is 3.56. We need this angle theta. That means we apply the cosine rule, which is 3.56 square is equals to 7.9316 square plus 7.9316 square minus 2, 7.9316 times 7.9316 times cos theta. Make cos theta the subject. Cos theta is equals to 7.9316 square plus 7.9316 square minus 3.56 square divided by 2 times 7.9316 and again 7.9316. Take cos inverse of this fraction and you should get 26.6 degrees. 26.6 degrees correct to 1 decimal place. Part D, part 1, the angle of elevation of x from A is 77 degrees. Calculate the height xy of the mast. Alright, part D, the angle of elevation of x from A. So this angle here is 77 degrees. So I'm going to redraw this figure with a better orientation. This angle is 90 here, and this is x, y, this is A, and this angle is 77. We already have the length AY, which was 2.58, and now we need the height xy. So simply apply tan theta. Tan 77 is equals to xy over 2.58, which gives xy is equals to 11.18. D, part 2. Calculate the angle of elevation of x from the midpoint of AB. So this is the triangle in question. The length xy is 11.179. I'm using the unrounded off answer from the previous part. Then this is the midpoint. Then what will this length be? We know this, the whole length is 3.65 from the start of the question, so we need half of that. So this length till M is 3.65 divided by 2, which makes this 1.825, and we need this angle. So we need this angle. This angle is a right angle triangle, and we will apply tan theta on this. Tan theta is equals to 11.179 over 1.825, and when you will take tan inverse, you will get 80.7 degrees.